The last that remains is sets, and I haven't used this thing very much actually. This is actually very simple. It is also stored in curly brackets, okay, just like dictionary, but it does not contain key value pair. It contains independent values. Okay, so let's say I have defined a set like this. Okay, it's like this. Let's see if indexing works here. No, indexing does not work with sets. Okay, if I check the length of this set, I'll get 4. Okay, I'll put it. Okay, but the actual use case of set is it stores unique values. Like even if you say set equal to 1 1 2 2 3 3 3, and if you print set, you'll get 1 2 3, and it also makes things in order. Like if I put 1 at last, still I'll get 1 2 3. Okay, because it sorts thing when it stores. Okay, is this clear? If I try to store multiple data types, we can see if it supports. Let's say 1 2. Okay, it can store multiple data types also. And if I want to test sum function, will it work? Sum of s. Okay, sum works. Minimum of s, it also works. Max of s, it also works. Okay, so basically it stores unique values. Now there are two operators of sets. 3 4 5 6. Okay. Uh, Cool. So intersection of this will give me 3 and 4, right? And union will give me 1 2 3 4 5 6. So if I do S1 and S2, so this is the intersection. Okay, S1 and S2. Now if I want to do the union, it will give me S1. Sorry, this is the union sign. Okay. And you guys know the difference of set? What is S1 minus S2?
1 2
1 2.
1 2 5 6.
1 2 5 6.
Very good. And S2 minus S1 will be 5 6. Okay, so these are the data types that you can use with sets. So for intersection, you use ampersand. For union, you use this difference, you directly use subtraction. So these are the three operators for sets.